Hi boys and girls, this is for reviewing the workbook pages you did last week on technical texts. And also I'd like to preview next week with you when we finish. Okay, first of all, understanding technical texts, I'm on page 38. We started with the smash-a-mole recipe. You can see some things that I underlined that I thought were really important. Feel free to pause this anytime or go back to it if you need to. Basically, I underlined that a procedure is a sequence of steps followed in order. So when you make a recipe like smash-a-mole, it is important to put the steps in order. And basically, if you want to pause and look at this was reviewing the smash-a-mole, what steps were in what order, and also why you did each step. So let me just review that quickly with you. The first step was the fourth one down. You peel the avocados and remove the pits. Wash the cherry tomatoes. Why? Because you have to prepare the ingredients before you put them in the bag. You don't want an avocado with a pit, and you don't want dirty cherries in there. The second one was given to you at the bottom. Then you put the first four ingredients, which were the 2 avocados, the cherry tomatoes, the onion powder, and the lime juice. You put those in a bag, zip up your bag, and squeeze out the air. And why you do that, you zip the bag so that the ingredients don't spill out. Another thing is, if there's air in there and you smash it later, it could pop the bag open. Excuse me. The third one was the second one down. Put the first bag into the second bag. Zip the second bag closed. Why? Well, it gives us that answer. When you use the second bag, it keeps the food safe in case rolling the can on it breaks the first bag. Okay, fourth, they've given us the fourth step. You roll the can over the bags until the food is mashed and mixed. Why you do it? Simply because doing that, rolling the can over the bags, mashes and mixes the food. And fifth is the third one down. When everything is smashed, open the bags, put the smash-a-mole in a bowl, use as a dip for chips. And the reason why is you put the smash-a-mole in a bowl so you can scoop it out with chips. If you did this recipe, tell your parents to let me know on the Remind app. I'm tempted to buy those things and make it myself. I'm getting hungry. Next was about finding your pulse rate. And the close reader habit said, as you read, circle words such as then and after that show the order of steps in finding a pulse rate. So you can see what I circled. And it looks like in the first paragraph there was nothing. Second paragraph I got first and then. Third paragraph after, then, and next. Fourth paragraph after. Now on the page 41, how do the details about taking a pulse add to your understanding of why your pulse rate is important? Listen to the directions. Number 1, complete the sequence chart below by writing the first 2 steps you must follow to find your pulse rate. Then explain why you need to complete the steps in order. The first step, it says first, place your index and your middle fingers on the thumb side of your wrist, this side of your wrist, slightly below the base of your thumb, okay? The why you do it is you need to find your pulse in order to feel your heartbeat. The second step is press gently until you feel the beat of your pulse. And it may take just a moment. The reason why you need to feel the beat in order to count the number of beats. You can see it here in case you want to check your answers against these answers. Lesson 3 was making a rhino bank. This sounds fun as well. Close reader habit says, why must you follow the steps in each part? Reread the text. Underline the details that tell you why you must follow the step. At the end of paragraph 2, it tells you to do some things, and then the last sentence says, this is, after all, a rhino bank. So that's why you use the shapes it's telling you. In part 2, the last sentence, if there is too much paste, the strips will not lie flat and might not even stick to each other. And in paragraph 4, part 3, we underline the part of the first sentence that says the paste will be dry and the shape will harden. Here it is if you want to look at it. Looking across, you have some questions. Question 1, part A, says which statement best explains why you need to use a balloon? You have 4 answer choices. The balloon holds the rhino shape while the pasted piece is dry. The pasted newspaper will only stick to a balloon. The balloon makes the bank look like a rhino and not like a pig. Or the balloon will keep the newspaper strips from getting too much paste on them. A is the correct answer. The balloon holds the rhino shape while the pasted piece is dry. Part B, underline one sentence from part 3 that best supports your answer to part A. They did the first line. After 24 hours, the paste will be dry and the shape will harden. Okay, so look at this, A, and then the first line. As you notice, I underlined some things in the top part, and I underlined and circled some things in the right. In talk, it says, explain why you need newspaper and paper mache and what you must do with them. Use the sequence chart on page 45 to organize your thoughts. Discuss why the steps in part 2, not the whole thing, but just in part 2, are important to the process of making the rhino bank. And also your short response goes with that. You're using the information in your sequence chart to explain the purpose of part 2, why is part 2 important to the procedure. So we're going to focus on part 2. Let me just read part 2 real quickly before we go on. Part 2, dip 1 strip of newspaper into the paper mache paste. Use your fingers to squeeze extra paste back into the bowl. Then stick the pasted strip over the balloon and smooth it down. Continue dipping and placing strips one at a time until you have completely covered your creation. Do not use any more paste than is necessary. If there is too much paste, the strips will not lie flat and might not even stick to each other. They may start sticking to your fingers. That's one possibility. Okay, look here at the rhino bank, and you see the chart. I have 4 steps. You don't have to put it quite as many, but if you do use 4 steps, the first step is you dip 1 strip of newspaper into the paper mache paste. Why do you do it? So it will stick to the balloon. Step 2, use your fingers to squeeze extra paste back in the bowl. Why? Too much paste, it said the strips won't lie flat and they may not even stick together. Step 3, stick the pasted strip over the balloon and smooth it down. And why do you do it? It says you want a smooth surface. Step number 4, completely cover the creation with the strips. And the reason is you don't want the balloon to show because that part of it wouldn't be hard. Plus, it just wouldn't look as nice. Okay, now the short response is asking you to tell the purpose of step 2. Or part 2, excuse me. So the purpose of part 2 is to create the outside shape of the rhino bank. In part 2, you soak newspaper strips in paper mache paste. Then you squeeze off extra paste and place paper strips one at a time over the balloon to cover the body shape. That's all the teacher workbook said, so you may have added more. I just realized too that I forgot to go over page 44. This was the writing about finding your pulse rate. And the short response simply said, explain why it's important to know how to find and check your pulse rate. It's important to find your pulse rate since your pulse rate can tell your doctor how your heart is working. It's also important to check your pulse rate because it can give you information about your health and fitness. So here is a picture if you want to stop and look. Then we go to our lesson 4 about floating or sinking liquids. You have some words to know here. Dissolved and particle. And I like this experiment because it gives you step-by-step and some really good pictures, visuals to go along with it. Let me read this before we go over. First of all, and I'd love to know if you actually did this, but you can still do it. It says you'll need 1 plastic drinking straw with stripes. If you can't find one with stripes, maybe we can see another way to measure that. You need scissors, a small lump of clay divided into 3 equal pieces. You could try Play-Doh, it might work. 3 clear glasses or plastic cups of the same size is important. 1/2 cup of water, 1/2 cup of vegetable oil, 1/2 cup of maple syrup. If you don't have maple syrup, any syrup's fine too. Okay, floating or sinking liquids. Many liquids mix easily with water, but some float on top of it and others sink below it. That's because each liquid is different in many ways. One difference is that each liquid has its own density. The more dense or heavy a liquid is, the more easily things will float on it. To find out about the density of liquids, you can make a tool called a hydrometer. Then use it to perform a fun experiment. Step 1. Cut the drinking straw into 3 equal pieces. Number 2. Form 3 small clay balls. Make them larger than the hole in the straw. Be sure the balls are equal in size. Step 3. Insert one end of each straw into the ball of clay. Be sure to center the straws and push them into the clay to the same depth. The 3 hydrometers should look the same. Boys and girls, I'm sure you've learned about this in science, but when you're doing an experiment, you only want one variable. That means you only want one thing to be different in the experiment so you can really tell. That's why the straws need to be of equal length and the clay balls need to be equal in size or as close as you can to that. Step 4, label each cup. Write water, oil, or syrup on the container. Step 5, fill each container with one of the liquids. Be sure the containers have equal amounts of the water, the oil, and the syrup. So the measurement needs to be equal even though the liquid is different. Step 6, carefully place a hydrometer into each liquid so it stands as straight up and down as possible. Also, make sure no liquid gets into the straw. Step 7, observe what happens to each hydrometer. Compare the different levels at which the hydrometers float. You will see that the hydrometer in the oil sinks the lowest. The hydrometer in the syrup floats the highest. So if you don't have a straw with stripes, I think it's okay to use a regular straw. You can still see, even looking at the clay balls, which is sinking the most and the least. Okay, let's turn the page to page 48. Now this is explaining how density works. It says, your hydrometers float at different levels because the water, oil, and syrup have different densities. The density of each liquid is determined by number 1, the size and weight of its particles, And number 2, how closely its particles are packed together. The heavier and more closely packed the particles are, the more dense the liquid. Paragraph 4. When a hydrometer is placed in a dense liquid, the packed heavy particles will push harder on the hydrometer. As a result, the hydrometer floats higher than it would in a less dense liquid. Paragraph 5. Weight plays a key part in density. For example, imagine one container filled with foam balls and one filled with metal balls of the same size. Both containers are packed with the same number and size of particles, but the one with metal balls would be much heavier or more dense. Lift each container to see which one is heaviest. It will also have the densest material. So density and weight go together. And here you can see a picture. See how closely packed or dense the particles are in the syrup, and how very far apart and less dense they are in the oil, and the water is just in between. Now you also have something that you can modify your experiment with here. Let me read that in the green box real quickly. Add 2 tablespoons of salt to the container of water. Stir until most of the salt is dissolved. You've packed more particles into the water, so now it's denser. What effect will this change have on the hydrometer? Okay, now let's look at the questions on page 49. Number 1, what is the meaning of the word perform as it is used in paragraph 2? Listen to paragraph 2 again. One difference is that each liquid has its own density. The more dense or heavy a liquid is, the more easily things will float on it. To find out about the density of liquids, you can make a tool called a hydrometer, then use it to perform a fun experiment. So would that mean to do or carry out? B, to entertain an audience? C, to participate in a tradition? Or D, to use a special skill? The answer is A, to do or carry out the experiment. Number 2, part A, how do the clay balls keep liquid from getting into the straw during step 6? A, they cause the straws to sink. B, they help the straw stand up straight. C, they cover the hole at the bottom of the straw. And D, they make the liquid denser. B is close. They help the straw stand up straight, but the main reason is C. They cover the hole at the bottom of the straw, and the water can't get into the bottom of the straw that way. Part B. What evidence from the text best supports the answer to part A when we said they cover the hole at the bottom of the straw? B is the right answer. You make the clay balls larger than the hole in the straw. That way they cover up the hole completely. Number 3, why is it important to make all the hydrometers the same? The answer is B, to get results that are accurate. So here are the answers again if you want to stop and look at them. Okay, look at page 50, number 4. What do the actions of the hydrometers in step 7 help you understand about the density of the 3 liquids? Going back to step 7, it says, observe what happens to each hydrometer. Compare the different levels at which the hydrometers float. You will see that the hydrometer in the oil sinks the lowest. The hydrometer in the syrup floats the highest. So the question again, what do the actions of the hydrometers in step 7 help you understand about the density of the 3 liquids? A, syrup is the densest liquid. B, each liquid has the same density. C, oil is denser than water or syrup. Or D, water is the liquid that is at the least dense. A is correct. Syrup is the densest liquid. If B was true, each hydrometer would be at an equal level. C, if C was true, then the hydrometer in the oil would be the highest one up. And D, if D was true, then water would have the hydrometer that sunk the most. Okay, now look at your box here on number 5. It lists some answer choices that you're going to use in the chart below, and it has some reasons. So all you have to do is choose. This is what the hydrometer does. With oil, it sinks the most. The reason? It has loosely packed particles. With the water, it sinks less than one, but more than the other. The reason? Its particles are packed tighter than one liquid, but not as tight as the other. Syrup, it sinks the least. The reason? It has tightly packed particles. So there are your answer choices. Okay, let me look over at your short response. I'm just going to read this from the teacher book because my hand got tired of writing. So now remember, yours doesn't have to be exactly like this, but listen to this one. It's page 51. It's your short response. It says, explain why the hydrometers float at different levels on the water, oil, and syrup. Use details from the text to support your response. Here is a sample response. The hydrometers float at different levels because the 3 levels have different densities. The syrup is the densest, so its particles are pushing up hardest against the hydrometer. That makes the hydrometer float higher than it does in the other liquids. The oil is least dense because it has lighter particles, or particles that are not packed closely together. So the hydrometer sinks down farther than it does in the other liquids. It doesn't mention water, but you could talk about how the water is in between both of those with this density of its particles. Now, let me talk to you about, sorry, I was about to end this. Let me talk to you about what I want you to work on this coming week. It's understanding scientific texts. So if you like science, you should really like this. It's talking about what happens, how and why, which goes along with the last lesson in the technical text that we just went over. It has something about fossils, something about coal, something about gold. Okay. And then minerals at the very end. So take your time and do your best on this. The writing this week is talking about that science. There are many different branches of science, like biology is the study of living things like animals, plants, humans. You have astronomy, which is the study of outer space. You have physics, which is the study of energy and motion. You have chemistry, which is the study of different chemicals and doing experiments with those kinds of things. You have geology, which is the study of the earth and dirt and all of that. There are other types of sciences also, but what I'd like you to write about this week is name your favorite branch or type of science that you enjoy or you're more interested in. Give at least 3 reasons why you're interested in that, or just give 3 details about that specific area of science. Then read as much as you can this week and play outside a lot too. This is just a really pretty time of the year. Talk to you later.